Hi everyone, and welcome to part 2 of today's little video session. This is a video about power and energy and paying for electricity and gas in your house, and a little bit on efficiency. Hopefully it won't take us too long. So let's talk first of all about energy. Now most of you were very good at knowing that this is measured in joules, and I was talking a few minutes ago on the other video about standard units, and the standard unit of energy generally is the joule. Okay, so measured in joules, and it is the ability for things to happen. So it's the kind of stuff that allows for work to be done in terms of physics work, stuff to happen, so things to move around, things to be lit up, that kind of thing. So it's an abstract concept. We just need to understand for the time being how to work it out. So I'll remind you of the formula, and actually we've got quite a lot of formulae now, so it might be worth making a little page in your book with some of these on. I'll go through those at the end of this video, the ones that we've done so far. So energy is power times by time. Okay, so we need to know what power is in order to work out what energy is. So power is something that we weren't very sure about. It's got its own unit as well. It's measured in something called watts. And what a watt is if 1 joule of energy was transferred in 1 second, that would mean that 1 watt of power. Okay, so it's how many joules of energy are transferred in 1 second. So another example, let's say a light bulb or something transfers 40 joules of energy each second. What that means is it will have a wattage of 40 watts. That's its power, 40 watts. So that's what power is. So when we come to working out fuel bills, basically what we want to do is we want to know how much energy has been used by a person each month. Okay, so for the purpose of fuel bills, we don't actually use the unit joules, because they would be too big. The numbers would be too big. So if you look at this formula, okay, and think about it, I'll write it again down here so we can see it. Energy equals power times by time. Okay, so if we put the units that standard units for a house in, so most things that you use, microwaves, televisions, ovens, dishwashers, will have a power rating on them somewhere, probably written on the plug or something, or on the back of them, and that will be measured in kilowatts. Okay, so remember 1 kilowatt is equal to 1,000 watts. Okay, so if you want to convert between them, if you want to convert watts to kilowatts, you need to divide by 1,000. 1,000 kilowatts. 1,000 divided by 1,000 is 1. Watts. 1,000 divided by 1,000 is 1 kilowatt. If you want to convert from kilowatts to watts, you need to times by 1,000. So because they are equivalent. So it doesn't matter whether this doesn't have to be 1. It can be any number. If you want to go convert from kilowatts to watts, times by 1,000. If you want to convert from watts to kilowatts, divide by 1,000. Anyway, in the home, kilowatts is our kind of unit that's used in terms of power. So if you've got a 10 kilowatt, I don't know, light bulb, what that would mean is that every second we're doing a kilojoule of energy transferred every second. So then we want to know, okay, so in a month, how much has somebody used their thing? All of their different appliances will have a certain power. They will have been transferring energy every second. They'll have a certain number of kilowatts that have been kind of transferred over that time, and we use hours as well. Okay, so this HR means hours. So sometimes, in fact, probably a bit more correctly. You often see it written like that, but usually it's just H. Sorry, I'll take that R out. So kilowatts times by hours. So if you look carefully, rather than messing around with joules, if you times these together in terms of algebra, you're going to get kilowatt hours. Okay, times together. It's not kilowatts per hour. It's not how many kilowatts are being transferred per hour. It's kilowatts times by hours, kilowatt hours. Okay, and if you think about it, okay, well, that must be a unit of energy. So we don't use, so that you could say kilowatt hours equals kilowatt hours. So it's like saying 2 equals 2 or 4 equals 4. So this in itself is a special unit only really used in electricity bills, and it measures energy. So because we know power times time, kilowatts times hours would equal energy, energy can be therefore measured in kilowatt hours. Okay, now I thought it might be a good idea at this point to show you my own fuel bill so that you can see what I mean. Okay, so let's just have a look at that. I'm going to switch this light off so you can see it. It's reflecting at the moment. Switch off. There we go. Right, so there's my fuel bill from December to January. Okay, so this is my real fuel bill, and you can see in that time, so there's my month long, I have used in my house 152.8 kilowatt hours. Okay, sometimes referred to as units of energy. Okay, so that's every time I've run my oven and all my lights and everything, charged my phone, everything I've used in the house over time, if I times all the kilowatts times by the number of hours I've used them, I've ended up with this much energy, 152.8 kilowatt hours. This is how an energy measure, how much energy I've transferred, because switched itself off. There we go. Because that is a measure of energy. Now the cost of my electricity and my energy is 14.1 pence per, that P slash means per kilowatt hour. So the way that they've worked this out, they've said, right, Miss Shakespeare has used 152.8 kilowatt hours worth of energy, and each one we're going to charge her 14.105 pence. Okay, and so if you multiply, and you can do this on a calculator, this number and this number, they will have ended up with this total. So my total energy expenditure, I don't know why it keeps doing that, it's when it runs out of light. Oh dear, switched off now. Okay, go back again, there we go. So they've multiplied these two together. If you do it on a calculator, you'll get the cost. Okay, and the way that they've worked this out, now I'm not very good at sending in my electricity bill, so you can see that this has been estimated for me because I didn't bother to send the number in. I do sometimes. It gets more accurate if they have the number, but let's imagine this wasn't estimated. So this was my previous meter reading, and this was my current meter reading. So over a month you can see the number has changed by 152.8. So every time the meter changes, it's clocking up a kilowatt hour. Okay, so that's what that is. And then they've added some other charges to my bill, which presumably are in my terms and conditions I have to pay, and then that's my total bill. And this comes for me every month. Some people get it quarterly, which means every kind of quarter of a year, so every 3 months, etc. So that's what a kilowatt hour is. It's confusing because a kilowatt obviously is a measure of power and an hour is a measure of time, but a kilowatt hour, when it's all combined together like that, is a measure of energy. The reason being, to work out energy you need to do power times time. So this is an energy unit. Okay, like joules is also an energy unit. So I can see why that was causing a few issues. Okay, lastly then, just before I log off for today, I wanted to talk a little bit about efficiency. Oops, can't spell. Efficiency. Oh dear, let's start again. Efficiency. There we go. Oh, now you can't even see it right there. Okay, so efficiency basically is how much of the energy, how much of, I know what I've done, I've put that down, that's why. How much of the energy put in is actually transferred as useful energy. Okay, so the maximum efficiency would be 100%. So if I put, let's say, so we tend to use a Sankey diagram, which is like an arrow. So let's say we put 100 joules of energy into something, let's just say a light bulb, and it transferred 100 joules of energy as light, then you can't get more out than you put in, because you can't make energy, we know that. So 100 in, 100 out, that means that we've not lost anything, we've not dissipated anything. This would be 100% efficient. Okay, but that's not, unfortunately, the reality. A lot of energy gets wasted or dissipated elsewhere, so you end up with something like more like this. So we've got our 100 joules of energy in, and we might get 30 joules of energy for light in our light bulb, and then that would leave us, remember, with 70, because 30 plus 70, so we'd get 70 joules, almost certainly going to be heat. You might get some sound if it's buzzing or something. So this is the useful energy, and this is not useful. This is dissipated energy that's just going to go to the surroundings and not be very helpful to anything. So we've paid for this amount of energy, but you can see we lose a lot. Okay, and this kind of brings into what I was talking to you about the other week about the efficiency of appliances, and you'll see one of those, I think, in the work that I've set for you. So the better the appliance, like something like a dishwasher, the more efficient it is, the more energy you're paying for actually goes into washing your dishes and not into losing it as heat. Anyway, to work out the efficiency of this, all we need to do is we take the useful energy and we divide it by total energy, all the energy that we put in, and then we times by 100. What we're effectively doing, I've run out of space again, there we go, is we're working out a percentage. So for my example, we've got 70 wasted, 30 useful. So we would do 30 divided by total 100 times by 100. So 30 divided by 100 times by 100. So essentially we're doing, basically we've just divided and times by the same thing, so we can work it out in our heads probably. So that would be 30%. The efficiency of that light bulb, whatever I said it was, light bulb, yes, is 30%. What that means is 30% of the energy we put in has gone into its function, transferring as light, and we've lost the other 70%. The better this number is, the more efficient your appliance, and also the kind of more cost effective your home is. This would be the ideal if you're 100%, that shouldn't be a light, should it? It should be electricity. 100% electricity went into 100 joules of light went into 100 joules of 100 joules of electricity went into 100 joules of light. That would be the ideal. Unfortunately, that isn't the case. While I'm just here, in the next 30 seconds, I'm just going to write down for you so that you can kind of start making a page of formulae if you want to. Some of the formulae that we have met, because it would be useful to start making a list of these. So maybe find a page and write some of these down. You might start remembering them. So speed equals distance divided by time. We've done that one. Now, the other thing, remember, is that you, as I showed you in the video that you watched earlier today, you can start rearranging these if you want to. You could make distance the subject or time the subject. The subject is the thing at the beginning. So it is important that you start trying to remember how to rearrange these, and I'm going to speak to Mr. Wilkinson about how much practice we need to give you on that. Anyway, speed equals distance over time, so usually meters per second, meters and seconds, but it could be miles and hours, in which case it would be miles per hour. Okay, what else have we done? We've done force equals mass times acceleration. That's Newton's second law. So often just F equals ma. Quite often S equals d over t. It's easier to just remember them so long as you know what the letters stand for, as just little 3-letter formulae. We've just done E equals pt, energy equals power times time. There's probably more that we've done which I've now forgotten. I suppose if you want to, you can have weight equals mg, although remember, as I just told you in the previous video, this and this are the same. If I think of some more, or maybe you can find some more in the things we've done, then let me know and we'll keep adding to this page. It's best to write them out like this to remind you what the units are, and then you can add in the little formula if you want. So remember newtons, kilograms, meters per second square there for that one. Then energy, you can either have joules, watts and seconds, or kilowatt hours, kilowatts and hours, depending on where you're using it, whether you're using it for fuel bills or whether you're working out in joules. And it's always one of those things you have to look at what they've given you as to work out which units you're going to use. Okay, units is something we come back to time and time again, so don't worry too much if this is causing you problems. Okay, let's leave it there. Enjoy the rest of your learning. Goodbye.